Hello everyone, consider this as your first class in information theory and coding. Okay, so here we are going to start with the first module. So this is the portion for the first module, right? The first module, there are two chapters. First chapter you're going to learn is the introduction to information theory, and the second chapter is source coding. So inside information theory, you need to understand what is information, okay? Concepts of information. Then you're going to study the units of information. Then what is entropy, right? The concept of entropy. Then the different types of entropy, that is marginal, conditional, and joint entropies. And then you're going to study the relationship between these three entropies, okay? Then you're going to learn about mutual information followed by information rate, okay? Each of these topics are very small, and also they're very easy to understand. And out of all this, from experience, I believe that these two topics is the most important. That is the entropies, marginal, conditional, joint entropies, and the relationship between entropies. Because this is where most of the problems they'll ask in the exam. Okay. Then the second chapter is source coding, that consists of instantaneous codes. Then the construction of instantaneous codes. How do you construct an instantaneous codes? Then you have the Crafts inequality followed by coding efficiency and redundancy. So this is the portion for the first module. So here in this video, we'll just start with the first topic, that is the concept of information. So what is information? This is something which you have already heard in your school days, right? What is information? Information is the reason behind every communication system, right? This is a textbook definition. It is given by, it is the commodity produced by the source for transfer to the user. A commodity. A commodity means it can be it can be a product, or it can be a image, or it can be any type of a signal, right? Or in other words, it is that thing which we want to send from one end to the other end. That is what you call as information, the essence of the communication system. It is not the signal, it is not the message, it is what the message is about. That is what is more important than the message itself. That is information. Okay. Let's for example, what example should I take? Okay. Assume that you are going to assume that you are watching a movie for the first time. Okay, you are watching a very nice movie in the television for the first time, and you don't know what the story is about. Okay, but if you are not able to understand what the movie is, then you find the movies to be very boring for you, right? If you want to enjoy the movie, first you have to understand what the movie is trying to say. For that to happen, the television will generate the audio signal, and it also generate the visual signals, right? The audio signals will be picked up by the ears, and the visual signals will be received by your eyes. And then both these signals will reach your brain, and then your brain will interpret these signals. And that's how you understand the movie. That's how you receive information. That's how communication is actually complete, right? That is, this is what the information is like. Information means what the receiver is trying to understand. See, for example, let me just draw the basic communication system. We all know that the basic communication system consists of a transmitter, or you can also call this as a source, right? This transmitter will pass a series of messages or signals through a channel, right? And this channel is also called as a transmission network, or whatever. It can be an air, or it can be space, or it can be through any medium, right? And then finally, through this channel, it will reach the receiver. You can either call this as a receiver, or you can also call it as destination. Okay, so this is the basic building blocks. This you already know, the basic elements of a communication system: transmitter, channel, and receiver. Okay, so here the transmitter will transmit these messages, and then of course there might be an encoder over here, there might be a decoder over here. That depends on the type of communication system you are handling, right? So the transmitter will transmit some series of messages, and then through the channel the messages will propagate, and then finally it will reach the receiver. Okay, so where does this information actually comes in this communication system? Where is this information is coming from in this block diagram? Where is this information? For that, you need to understand that in this communication system is actually successful if and only if the receiver is able to interpret what the transmitter is transmitting. If the receiver is able to understand what the transmitter is trying to say, then I could say that the information is successfully passed from here to here. This can be your TV, this can be your brain. This can be some kind of a news reporter presenting a news, and then this will be might be your antenna, right? That you fix on top of your roof, right? So there are different ways. This can be a radio, this can be your ears. So therefore this it's not just the message that's being passed through. The receiver should be able to understand the message. It should be able to interpret or decrypt the message. Then only we can say that the communication system is complete or it is successful. Okay, so that is what is information is, right? So what is the difference between information and a message? You see, that is one thing you need to understand over here. That is information. If I want to make it in a very simple definition of information, information is nothing but how much you don't know about a particular situation. That is information. Something which you never heard of, or something which you don't know will happen or not. You might expect it, okay? You might know it might happen, but you are not completely sure. You're not completely aware. For example, you are waiting for your exam result, okay? You don't know how much mark you will get, okay? Sometimes you have if you have done very poorly, sometimes you might expect you will fail for that exam, or sometimes you have done well and you expect to get very good marks for the exam. But whatever it is, you might have some expectation from yourself, but you don't know the actual result. Knowing the actual exam result, that is information. It is nothing but the amount of uncertainty. Hope the spelling is correct. The amount of uncertainty, that is information. The amount of uncertainty, or if you want to make it even more simpler, information is nothing but the amount of how surprised are you. That is information, the amount of surprise, right? So this means that, you know, just to give you a good idea what is information, right? I have taken some 4 examples over here, okay? 4 events, okay, that could happen in our daily lives, okay? That could happen or may not happen in our daily lives, okay? So let's look at each of these 4 events, and then you will understand what is actually information, okay? You see, like I said, remember, like I said, it is the amount of uncertainty or amount of how much you don't know. That is information. So let's look at these 4 events. The first event, okay, the sun will rise in the east, okay? So just by reading the statement, how much information have you received? None. Nothing. Because we all know that the sun rises in the east. You have already learned that in the school days. So me saying this sentence to you is nothing new to you, right? Because you already expect that the sun will always rise in the east. It rose today, it will rise tomorrow, and it will rise even 100 or 1,000 years from now, right? So there is no change. There is no information that you will get just by reading the sentence, because this is basic knowledge that the sun will rise in the east, okay? Now, what about this sentence? Tomorrow will be a rainy day, okay? Well, I kind of expect that it will be a rainy day, but I don't know it will rain or not, okay? The funny thing about the sentence is that I wrote the sentence last night, okay? And today, right now, the rain is going on outside. So this actually happens to be true. This just because luckily this became true. So one thing about the sentence is that you kind of expect it, but you don't know whether it will happen or not. But once when you in the newspaper, when this message comes, then you will realize, okay, so tomorrow will be a rainy day. So you receive some amount of information, right? So if you compare these 2 statements, the first event does not give you any information because you already know this will happen. Whereas the second statement, you kind of expected it. All right, you kind of know it. You don't know if it will happen or not, but you kind of expected it. That is this information, okay? Now, let's look at the third sentence, all right? the number of COVID-19 cases has decreased rapidly. We all know that in so far the newspaper headlines, they're saying that the COVID cases are actually increasing, right? Then one fine morning when you take the newspaper, you read that instead of increasing, now they're saying it decreased, and that too it decreased rapidly. Miraculously something happened and now the COVID cases has been declining. So when you read this case, you kind of get shocked, or you kind of get unexpected, because you never thought this will happen, right? You never expected that this will happen in the first place, right? So that is information. So this gives you more information than this and than this, right? This will give you more information than any of these two cases, right? Because why this thing gives more information? Because you never expected this to happen. Or in other words, the probability of this event from happening was very, very low, right? That is why you never expect. That's why this statement will give you more information. Now look at the last event. Okay, in the newspaper headlines, they might write this kind of a sentence: there will be a series of earthquakes in your neighborhood tonight. Now, when you read the statement, this will actually surprise you to your core. You will be so shocked that you don't know what to do, right? Why are you shocked? Why are you surprised when you're reading the sentence? It's because you never expected it to happen. The probability of this event was actually minute. You never expected it to happen, right? So when you read the sentence, if I'm saying it in another way, if these four sentences were put, hypothetically, if these four sentences were put in a newspaper headlines, then the one that will shock you the most will be this one. Because the reason is you never expected this to happen, or the probability of this is happening is 1 in a million. 1 is to 10,000 or 1 is to 100,000. You never expected this to happen. So this statement gives you the most number of information. Whereas this event, you also didn't expect that to happen, but it doesn't shock you, because we know that the vaccination is being developed as we speak, right? So we know this will happen somewhere in the future, but you just didn't know it will happen. So this will give you more information and lesser probability. Whereas this is kind of you expected by 50-50 chance. It might rain or it might be a hot sunny day, but you know something is going to happen. Okay, and this event is a sure event, right? It is a sure probability, and this sentence does not give you any information. So out of all this, as you go down, if you read down each and every events, then the amount of information is increased. That is, this statement receives the maximum information. Whereas what about the probability of that event? The probability of the event actually decreases. Here the probability of the event is actually 1, because we know that the sun will rise in the east. You are 100% sure about that. The probability is 100%. Or in other words, the probability of this event, that is, in other words, if you want to say, this is nothing but P of A is equal to 1, right? I'm just putting a number. So here, probability, the maximum value of a probability, we know it is 1, and the minimum value is 0, right? Always the probability, the values of probability is from 0 to 1. So in the first event, the probability is 1. The probability of this event from occurring is 1. What about the second probability? Okay, we don't know whether it might be a rainy day or a hot sunny day. So let's say that I'm placing the probability as equal to 50%. Okay, 1 by 2. Okay, I'm assuming that the probability of the event B is 0.5. Okay, here you never expected this will happen. Okay, this is a kind of might come up an unexpected for you. You'll be happy to hear it, but you never expected this to happen. So this will give you more information, but the probability of this was happening. The reason why this gives you more information is because, or the reason why you are more surprised is because the probability of this event was actually very small. I could say maybe, how much should I put? 1 by 8 maybe? 1 by 8, right? Or 0.125, right? That's because we don't really expect it. What about the last event? The last event is actually the one that gives you more information. And the probability of this, the reason why it gives you more information is because the probability of this event is totally unexpected. We never expected this will happen. I would like to say this will be nothing but 1 into something. 1 into 100,000 or 1 into 1 million or whatever. You see, because because we never expect this to happen. So out of all these four events, in summary, out of all these four events, which event actually has the least probability? This one. And which event has the maximum probability? This one. Here the probability is 100%. This is a sure event, right? So now let me ask you one more question. Which event gives you more information? This one. The least probability event gives you the more information. All right. And here, how much information is provided from here? It is 0. The information provided by this event, because we already know the sun will rise in the east. Okay. So this is giving you the least amount of information. So now, since you now understood what is information, right, and the correlation between information and probability, what do you understand about it? See, suppose if you want to derive an equation. Now, see, the reason why we are learning the subject is because we are trying to theorize or materialize the concept of information. Or in other words, I'm trying to express information on the paper. That is what I'm trying to do. Express the information in terms of an equation. Okay. So how I'm going to express it is by generating some form of formulas or some rules that I have understood from all you have learned so far. So what are the different concepts of information? First, you are going to find, or you are going to understand the different concepts of information. And then after that, you are going to look at, you are going to derive at an equation that satisfies all these concepts. Okay. So what are the different concepts you have understood about information so far? First thing you have understood that is that for any event or message, whatever, for any event A, we have, from here you have already understood that the information about an event is actually inversely proportional to the probability of that event. Right? That is the first thing you have understood about the examples that you have written. Here you can see that as the probability is decreasing, the information is actually increasing, right? The one that, like I said before, the event or the message that surprises you, or the message that you never expected, that message is the one that gives you more information. And the message that least expected, or the message that you have kind of expected, you already expect, that you know this will happen, that message will give you lesser information. Okay. So therefore, information is indirectly or inversely proportional to its probability. Okay. So that is the first concept you have understood. Okay. And the second concept you have understood is that if the probability of that message, of the probability of that event is 1, then the information provided by that event is 0. Taking the first case, the sun will rise in the east. We know that the sun will rise in the east. There's nothing informative about that. So the probability of that event is 1. It's 100%. It is a sure event, a sure certain event. Therefore, there's no information from here. Therefore, the information is equal to 0. Okay. So that is one condition. So this is the first concept, this is the second concept, and the third concept you want to have is that the information must never be negative. It must always be positive. We know that the values of the probability is always between 0 and 1. Right? 0 less than or equal to probability of A less than or equal to 1. So we know that the values of probability is between 0 to 1. So when the value of probability is between 0 and 1, the value of the information must always be greater than 0. It must always be positive. It must always be positive. That is the third condition. Okay. So now, like I said before, the reason why I'm developing these three concepts is because I'm trying to create an equation for the information. That is what I'm trying to do. I'm trying to create an information, the equation for the information. So you know that any function can satisfy all these three concepts. Any function. right? Exponential function or hyperbolic function or rectangular function or logarithm function or any function, you can use it to satisfy all these three concepts. But there is one more concept that you need to understand about information. And that is the sure and the final and the most important concept. And that concept is that suppose a transmitter, okay? Suppose a transmitter is trying to transmit two messages. A transmitter is trying to transmit two messages. One is called as the message A and the other is called as message B. Right? It is trying to transmit A and B, only two messages. So we don't know which message will transmit. It will either transmit A or it will either transmit B. Okay? And then we have a receiver. And the receiver will receive these two messages. Okay? The receiver will receive these two messages. So if the receiver receives message A, suppose if the receiver receives message A, then the amount of information received by the receiver is I of A. I of A, units of information. Units of information. And if the receiver receives the message B, then the amount of information received by the receiver is I of B, units of information. Okay, so in that case, the total amount of information received by the receiver is I of A plus I of B, which is I of A plus I of B. Okay, we all know this already, right? That is, if the messages are being sent in a series, then your information will also increase depending on the message, right? So first the transmitter transmitted message A, so the receiver receives the message A and then it will do some kind of decoding or decrypting or whatever, and it will receive the information regarding to message A. And after that, when the transmitter transmits message B, then the receiver will receive I of B. That is the information with respect to message B. So the total information received by the receiver is I of A plus I of B. Okay. Now imagine, alright, instead of this transmitter transmitting A and B in a series, assume that the transmitter is not transmitting A and it is not transmitting B. Instead, it is transmitting another message called C. And what a C is? C is nothing but the mixture of A and B. It is the composite message that contains both message A and message B. That is what this means. A dot B. That is, instead of transmitting A and B separately, the transmitter will now transmit only this message C, where C is nothing but the composite message of A and B, which means A and B are actually the sub message of this message of C, right? So instead of transmitting A and B separately, the transmitter will transmit C, and in that case the receiver will receive C. The receiver will receive the message C. Now, even if the receiver receives message C, even if the receiver receives the message C, I want the total amount of information to still be this. I want the total amount of information to be I of A plus I of B. Or in other words, even if these two messages are transmitted separately, or even if you are combine these two messages in some kind of a modulation or any format, whatever it is, the amount of information must always be additive. You need to add the information, whether you are sending the message in form of message A plus message B, or you are trying to send the information by message A into message B. Whatever it is, the amount of information must always be I of A plus I of B, whether it is plus or whether it is multiplication. It should be I of A plus I of B. Now, I am asking you, which function satisfies all these conditions? The thing is, lots and lots of functions satisfies the first three conditions, the first three concepts, right? This can be achieved by any function. All you need to do is simply put 1 by p in the equation. That's all. Simply put 1 by probability in the equation, and the first condition is satisfied. Okay. Whereas the second condition, only very little function is able to satisfy the second condition, and also the third condition. But only one and only one condition, one and only one function satisfies this concept. Only one function that satisfies this condition. That is, when the input is a plus b, or if the input is a dot b, the output will always be the sum, I of a plus I of b. Which function is that? Which function satisfies the fourth and the important condition? And that is nothing but, you already know this, log function. Logarithmic function. It is the logarithmic function that satisfies all these four conditions, all these four concepts. Or in other words, if you by satisfying all these conditions, I can say that the information of an event or the information of a message is given by log of 1 by P of A. The information about an event is given by log of 1 by P of A. This is the first equation you are going to study in this subject. The first equation. This information is called as the amount, this I of A is called as the amount of information received, or the amount of information of event A, or the amount of information of message A. That is I of A, also called as self-information, amount of information, amount of uncertainty, amount of surprise. Okay, and it is given by log of 1 by P of A. Okay, here you can see that you have to understand that log of a function does not mean that the base is always 10. Okay, it doesn't represent that base is always 10. It can be, the base can be either be 2, or it can either be 3, or it can either be 4, or it can either be 10, or it can be a natural log. Natural log means then the base will be equal to e, exponential function e, right? So so far I'm not specifying what the base is. I'm just representing the base as an unknown variable. Okay, but whatever it is, the most important thing is that the equation for the information is log of 1 by P, log of 1 by probability. Okay, why did I choose this equation? Is because this equation satisfies all these four conditions. For example, let's take the first condition. I of A is inversely proportional to 1 by P of A. That is, information must be inversely proportional to probability. Is it inversely proportional? Yes. See, inside the bracket it is 1 by P of A. So the first condition is satisfied. What about the second condition? If P of A is equal to 1, then I of A must be equal to 0. That is, for a sure event, no information should be, there will be no information if the event is a sure event, right? So in that case, substitute P of A is equal to 1. What do you get? Log of 1. Log of 1 to any base is actually 0. Log of 1 is always equal to 0. So I of A is equal to 0. So the second condition is also satisfied. And also over here, between the values 0 to 1, if you substitute any value between 0 to 1 over here, this value will never become negative. This value will always become positive. So the third condition is also satisfied. And last and not the least, the last condition is also satisfied over here. Right? Because we know that log 8, right? Log 8 is actually equal to log 4 plus log 2. Likewise, log 10 is actually equal to log 5 plus log 2, right? Log 6 is actually equal to log 2 plus log 3, right? That is, the product of two numbers is actually the sum of its logarithmic function. Its log function is actually the sum of its logarithmic function. So therefore, only logarithmic function satisfies all these four concepts. right? And that is why we derive that the information of an event is nothing but log of 1 by P of A units of information. Okay? So this is your first equation you need to study and understand. Okay?